It's my honor to introduce our second keynote speaker, Paul Joskow from MIT. Paul is the Elizabeth and James Clean Professor of Economics at Massachusetts Institute of Technology, MIT, and President Emeritus of Alfred Solon Foundation. Paul has been on the MIT since 1972, where he was the head of the MIT Department of Economics from 1994 to 1998, and director of the MIT Center for Energy and Environmental Policy Research from 1999 to 2007. Paul became president of the Solon Foundation in 2008 and returned to MIT in 2018. So it's a very great pleasure to have Paul here at TTU in our summer school. And today, Paul will talk about hybrid electricity markets. Paul, thanks for coming.
Thank you. Thank you for inviting me. Some of you have seen me walking around with a cane. Someone in the economics department tripped me 10 years ago at a dinner, so I fell hard on my knee. So it's not broken, but it hurts a lot. So I'll try to not use it because it usually just falls down after I'm using it, but I may sit down. So thank you for having me. It's nice to meet you all. I met some of you last night, and some of you on the way to lunch. So I'm going to discuss what I'm calling hybrid electricity markets, and it's really a longer title to support wind, solar, and storage investments and operations. And just as a, whoops, sorry about that. Is that better? No? How's that? If you can't hear, just scream. It's my students do, or walk out. Okay, so I'm going to talk about hybrid electricity markets, and I'm going to start to say what am I used by the term hybrid electricity markets? What are long-term purchase power agreements? Why has recognizing the existence of long-term purchase power agreements become more important? I'll talk some about PPA design issues, PPA procurement issues. I'll be focusing a lot on the US, so Dick gave you, I think, a pretty good introduction. I'll try to elaborate on some aspects of the US system that Dick didn't discuss. I would say that there's been relatively little systematic discussion of the role of purchase power agreements and their design in the operation and performance of wholesale markets. There's been much more discussion in Europe. Certainly in the UK, there's been a lot of discussion. I know David Newberry was here last year, and he may have discussed some of this, and I've learned quite a bit by talking with him, although the way it's happening in the US is quite different. And the focus is going to be on wind, solar, and storage. Obviously, there are other zero carbon technologies like nuclear. I'm just not going to discuss those today unless there are some questions about them. So, what is a hybrid market? Well, on the left of this diagram is the kinds of markets that Dick discussed this morning. Basically, short-term wholesale markets, and what's often referred to as competition in the market. Dick described some of their attributes, some of their issues, but I think overall they work fairly well. Now, to say that, it's 25 years since they were first introduced in the U.S., actually a little over 25 years. And it's been a process of continuous improvement, learning from mistakes. And that's true about what I'm going to call hybrid markets and the role of long-term PPAs. And This might be referred to as competition for the market, where counterparties, buyers go out and take competitive bids to provide a large quantity of electricity from wind, solar, or batteries for a long period of time, 20 to 30 years. So what is a long-term PPA? Basically, it's a 10 to 20 to 30-year commitment, a contractual commitment to supply power under specified terms and conditions. The kinds of terms and conditions are the price could be a fixed price per megawatt hour over a long period of time. It could be an index price. It could be seasonal prices that vary from season to season. It could be partially hedged. It could be, let's say, 90-20, a predetermined price and 20% a market price. It could be a capacity price, capacity, for example, per megawatt hour, and then the owner of the battery decides on when to charge and discharge it. It may have provisions for curtailments, and curtailments are increasingly a characterization of wind and solar generation, especially in areas without adequate storage. And then there can be provisions that deal with negative price contingencies, which are also a feature that has emerged over the last few years in U.S. markets and I suspect in European markets as a result of wind and solar in particular coming into the market. And then the quantity supplied can also vary. They could be all the output. We'll just take all the output. We'll pay you $50 a megawatt hour. Or it could be modeled output. I think did David speak about this last year? So David's very big on using modeled output, kind of a yardstick as a way of forming these contracts, which has some merits, but actually in the U.S. is rarely used. And then there are locational and delivery points, as Dick discussed. We have LMP in the U.S. There are many, many nodes in most of the ISOs that exist, and the question is, where do you have to deliver the power, and which price will you use? And I'll talk a little bit about that as well. So why have long-term PPAs emerged over the last few years? Well, one reason, and a primary reason, has been to reduce financing costs. Basically, the idea is that the buyer will be a very creditworthy buyer. And as I'll discuss, it could be a utility, it could be an industrial customer like Amazon, it could be an intermediary, it could be a bank. And the basic idea is that there are risks associated with wind and solar. And as discussed, the price risks are going to increase over time as prices will become more volatile as the diffusion of wind and solar increases. Suppliers also face market risk, especially for offshore wind, which can take a long time to build. I'll talk a bit about that. The long can be forever. But during the period of time as you sign the contract and the project is completed, costs for materials, for construction, for everything can increase. And that's something we saw after COVID as supply chains changed. Buyers, especially large loads, may also just be interested in a stable supply of electricity at a fixed price. Buying and selling electricity is not their primary business. Their primary business may be Bitcoin mining, but more recently, it's data centers that are either cloud-based computing or the development and application of large language models, which is growing very, very quickly in the US. But there are also some policy reasons. So we don't have carbon prices in the US. However, as I'll discuss, we have about 25 states that have made net zero commitments. For example, I live in Massachusetts, a very liberal state. blue as can be. 12% of the people in the town I live in voted for Trump. The rest voted for the alternative. And they've made commitments. They want the electric power they purchase to be 100% green by 2035. And they want the entire state to be green by 2045. That's their commitment. It's in a law. Are we going to reach it? No, but that's not the subject of my talk. But you can't get there just relying on the market. We don't price carbon emissions. It's an externality. And the latest values for the social cost of carbon in the US are approaching $200 a ton of CO2. Well, there is a regional market in the Northeast called RGGI, the regional gas market, greenhouse gas market, and it's now at $21. I just looked at it today. So it's 10% of the social cost of carbon. But moreover, we made these commitments without thinking about what their costs were. So if you really wanted the market to get there, in New England, you would need some very, very high carbon prices. Very high. Not $200, more like $600. I'll show you why the regions of the US are quite different in this regard. So they're just not going to work. So the states in particular, and that's why states are really quite important in the US, are pushing the system to become more green in a variety of ways that I'll discuss. And there's just a lot of aversion to putting a high price on carbon emissions and a desire to kind of hide the costs by using obligations, requirements, mandates, and subsidies of various kinds. So this is just something from Walmart's website, just to give you an example. Walmart has a net zero commitment of some kind that they've made. I picked Walmart rather than another state because Walmart's all over the U.S., even in Massachusetts. They made a net zero commitment. They started off trying to buy it on the spot market or one-year contracts. They couldn't come to agreement with the original developers of wind and solar facilities who wanted 20 or 25-year contracts. So they finally have come to a decision that they will sign PPAs that are on the order of 10, 15, maybe 20 years, and they would use the fact that they have a very high credit rating, basically to provide the developer that may have a rather low credit rating with financial security, and the PPA provides the backing for going to the capital market to borrow money to finance the development of these facilities. And David Newberry has done quite a bit of analysis in the context of the latest reform of the system in the UK. Maybe it's Great Britain, UK, I can never keep them all straight, all the aggregations. I think it doesn't include Northern Ireland. But basically he shows that if you can shift some of the risk to creditworthy buyers, in the case of the UK, the government, you can reduce the cost of capital very significantly and reduce the ultimate cost of the PPA. So that's what's driving this. So I'm going to focus on the U.S. Let me just say a little bit more about ISOs than Dick did. First of all, this picture, I want to make 2 points. First, it's not to show Canada as the 51st state. It turns out that for many years, the electric power systems between Canada and the U.S. are synchronized with one another. The major exception is Quebec, which has its own system, its hydro-based system. They export to the U.S., especially to New York and New England. However, integrating them into an AC system would be very challenging. So they're DC connected. But basically, the U.S. and Canada have integrated systems. But you'll also notice on this chart that there are blank areas. And there are blank areas because we have utilities, primarily vertically integrated utilities, that are not in any ISO. Up here, you can see that the US system is really quite complicated from an industrial organization perspective. There are investor-owned utilities, which are regulated by both FERC and the states, some of them are vertically integrated, some of them have divested their generating capacity, some of them are in ISOs, and some of them aren't in ISOs. But we also have municipal utilities. I'll give you some examples. And we have federal utilities. We have cooperative utilities. These are owned by the customers. Some of them are very small, but there are a few that are pretty large and own generating facilities. We have obviously independent power producers, and as a point I made at the end of Dick's presentation, every state except Nebraska has a state public utility commission. And they have substantial jurisdiction over retail customers, over the distribution system, and I know it's not well understood at FERC, but also over the transmission system in some states, depending on how they're organized. And so it's a complex regulatory scheme, and because it's the US, and if you follow the election, we have red states and we have blue states. For reasons a political scientist really has to answer is the blue states are the ones that have restructured and rely on competition, and the red states tend to be those that, that haven't, or if they've joined ISOs, they tend to still be vertically integrated utilities. So Dick talked about the ISOs. I'd like to just show you some examples. I won't go through what ISOs do because Dick discussed that. But here's PacifiCorp. This is a partially vertically integrated utility in the Northwest US. It's not in an ISO. It's owned by Warren Buffett's company, Berkshire Hathaway. They have an energy company. Their largest share ownership is in PacifiCorp, and it serves multiple states in the West. They also turn out to own Nevada Power, NV Power now, which is in Nevada, as a separate utility. And they operate in states, Washington and Oregon in particular, that have decarbonization commitments, tight decarbonization commitments. And then they also operate in, I think that's Utah, and they don't. So they face some challenges in how to balance their system. And they do it based on traditional integrated resource planning, what's the cheapest way of meeting our demand. And they've concluded they're closing their coal plants, and they're putting in investments, especially in wind and some in solar. Wyoming, which is up here somewhere, I guess there, Wyoming has a lot of wind, especially down here. Unfortunately, no one lives in Wyoming. There are a lot of cows, cattle, horses, rabbits, but less than 700,000 people live there, and that many people went to my high school in New York City. This is the Tennessee Valley Authority. That's in the southeast. That's a federal government owns it. It's not clear it's regulated by anybody. They were originally set up to basically build dams along rivers in the southeastern U.S. by Franklin Roosevelt. But they ran out of rivers to dam. And so they started building coal plants, and they started building nuclear plants. And they're a vertically integrated utility. And both of these utilities have entered into purchase power agreements with wind and solar facilities. And they have increasingly, as they've tried to meet decarbonization goals, and also responded to the economics of wind and power, wind and solar, which have declined fairly dramatically. That's the Los Angeles Department of Water and Power. It serves the city of Los Angeles and a few other communities in Los Angeles County. It's a real vertically integrated utility. It has transmission lines that extend up to Canada, into Utah, and to just outside of Phoenix, Arizona. They're regulated by some board of politicians, not by the State Regulatory Commission, and they're not in the California ISO. They weren't required to join. They have made some agreements with them on transmission to abide by FERC's transmission rules, but otherwise they don't participate in the ISO markets. They don't have to. If they volunteer, they can. Now, I will say in the West, and Dick made this point, there is an active bilateral trading market, and it's existed for decades. And it's basically unregulated. Utilities in the Southwest that are not parts of ISO can trade with each other. The ISO has organized a market or two markets, an imbalanced market and a day-ahead market, which these utilities can participate in or not. It's only partially integrated with the ISO itself, and the ISO has no control over things like transmission planning and other things that ISOs do. Another difference between the US and Europe is we don't have retail competition in most states. If you look at the map, we have complete open access for all kinds of customers in only about a dozen states. And again, I won't get into the politics of this, but these are all Democratic states. Those are Democratic states. They introduced comprehensive retail competition. Texas is a very red state. Ohio's a red state. They also have retail competition. But for the rest of the country, you have to buy your power from the local utility. And the local utility regulates it. The local utility may have commitments to buy green energy, wind, solar, and batteries, but that's up to the state to decide. And it's really the economics, the declining costs of wind and solar that have made it interesting to states without these mandates, the state mandates. Okay, so where is the wind and the solar? Unfortunately, it's not everywhere. So the big wind zones in the US are in the Great Plains, stretching actually into Canada, all the way down to northern Texas, the Panhandle, and along the Atlantic coast, especially up here, and along the Pacific coast. The difference between the Atlantic coast and the Pacific coast is the Atlantic coast, you can put wind, you've got to put it where people can't see it. I think Dick said they're too noisy. Well, if it's 35 miles away, it's hard to hear. So you get less opposition. Unfortunately, there are no incumbent transmission facilities 30 miles out in the ocean, but it's shallow. So they can use well-developed European technology to develop wind. And I'll come back and talk about that, because several European companies have had some bad experiences in the Northeast, especially recently. Along the Pacific coast, it's deep, and you've got to use floating windmills. And there really have been none developed there. If you look across the world, there aren't that many floating windmills, and I think that technology is still relatively new. So the wind belt is where wind is really important. Then there's some areas in northern Maine and in northern New York State, and in principle in the Great Lakes that are pretty windy. The problem is northern Maine looks great on the winds, but there's no transmission up there. There's nothing up there, actually. A few people live there. There used to be trees. They cut them down. They used to farm potatoes, not very profitable these days. So transmission becomes an issue for accessing these areas and bringing the power from where it's cheap to produce to where it's where you need it, where the demand centers are. So, for better or for worse, not that many people, and there's not that much load in that part of the United States. Now, sun is the same story. If you've been to the US, if you've been especially to the Southwest in the summer, it's sunny, it's hot, big empty areas, ideal for solar farms. The Southeast, it turns out, is pretty good, but the air is dusty. The air is dustier, and you get more reflection. And the Northeast, where we have all these commitments, is terrible. The economics of solar there are bad, and they've had to be subsidized very, very heavily. And they've especially subsidized rooftop PV, which for reasons that escape me are always outside the calculations. But that's been very important, especially in Massachusetts, believe it or not. Adjusted for population, is the third most solar-intensive state in the country because of massive, massive subsidies. Okay, so overall for the U.S., we have about 15% wind and solar. We still have quite a few nuclear plants. Coal has gone from 53% of electricity generation to 13, 14, 15, 16%. It varies by year. Last year was a little higher. But coal plants are retiring rather quickly, either for economic reasons, cheaper natural gas in particular, or because of this push to add wind and solar and the economics associated with that. But overall, you can see wind and solar is, this is March 2024, it's probably over 15, 16% now in the US. But it varies by state. Well, let me just make this point. If you look on the margin, this is before Trump was elected. Okay, this is in 2024. Almost all the new generation was wind, solar, and batteries. So the U.S. was on a path to decarbonization with a combination of federal laws, which I have time, I'll come back and speak about, state laws, which are binding in many states, and reductions in cost of wind and solar. Now the states vary. This is California, which has a net zero commitment. It also is the first state to develop wind. It has quite good solar resources, especially if they can be brought in from the desert with transmission lines, which are being built in California. And you can see that this is wind, and this is solar. That's thermal solar, which had a brief enthusiastic development. This is large hydro. They still have nuclear there. They have 2 nuclear plants operating, and they have no coal. It's gone. They have gas. They have quite a bit of gas, and they also have batteries. I'll come back to that as well. So they're on their way to decarbonization as a result of government policies, state policies, and federal policies. And this is Texas, ERCOT. This is an oil and gas state. But the economics are so attractive for wind and solar there that they've come into a point where Texas now has the largest generation from wind and solar energy. They still have a little bit of coal, they have a little bit of nuclear, but wind, natural gas, and solar are their big sources of generation. And as you might expect, since it was an oil and gas state, the governor is trying to do something about this. He thinks this is terrible. He thinks for reliability reasons, we need more gas plants, and they're in the process of putting in state regulations to try to restrict the expansion of wind and solar and to try to promote natural gas. Okay, so what are the attributes of wind and solar that are relevant here? Well, for my discussion, the primary attribute, aside from the intermittency issue, which the ISOs are trying to deal with, there are other attributes. Obviously, in the case of wind, it varies by time of day, it can vary by season, it's location dependent, its costs are mostly capital costs. This is the primary consideration. It has very small marginal operating costs on the order of $2 a megawatt hour. So the short-run marginal cost is very low. Inverter technology has issues, at least up until now. It's limited the provision of ancillary services without also having batteries. But smart inverters are being developed. It's a research area. And my colleagues in the electrical engineering department at MIT who work on power electronics assure me this will not be a problem in the future. I hope they're right. And solar has some of the similar attributes. It's intermittent. It's seasonal. Unfortunately, the sun doesn't shine at night. Someone ought to fix that. People always say, well, that's because the sun goes down at 7 o'clock. Well, the sun doesn't go down. The earth rotates. But nevertheless, for explaining it to your neighbors, you tell them the sun goes down. And then they say, well, what do you do then? I said, well, we still have wind, and we're going to have, we have batteries, and maybe we'll have some gas hanging around for quite some time. Won't be used much, but it might be used. But this is a real issue with systems that become solar dominant. You really have to worry about what you're going to do at night. And it's not just at night, again, because of the location of the Earth to the sun, you get seasonal variations. And because of cloud cover and storms, you can get hour-to-hour variations. So the intermittency is just not simple day-night. It's intraday, it's intra-seasonal, interseasonal, and again, that's something that needs to be taken into account. And that has become one of the roles of batteries. Now, I would say before 2020, before the outages in California in August of 2020, when they had rolling blackouts on 2 days and near rolling blackouts on another 2 days in August and September, they realized, man, we got to have batteries. So they ordered the utilities to put in thousands of megawatts of batteries, which they now have which they have in place now, and are designed primarily to deal with the net demand, that is demand minus wind, minus solar, starting at 4 o'clock and going until 8 o'clock. And they also have retail, this Public Utilities Commission in California has put in retail incentives to move flexible loads out of those hours. So especially for EVs, you have some choice as to when you charge them and how much you charge them. The one thing you don't want to do, which is what they've done, is to put in a peak load, a time of day pricing scheme where the prices go way up at 4 and then suddenly go way down at 8, and then everyone starts charging their car at 8. And that ends up blowing the distribution system. What you'd really like them to do is to spread it out over the network during the night using a smart charger and putting in how many miles you think you'll travel the next day and how much it has to be charged, and smoothing out your charges. I've written some papers on this, on separating the prices for energy from the use of the network, which can be especially important with flexible loads, EVs, and heat pumps, when storage in particular is available locally. So those are the attributes, and these are the technologies that have been brought in almost universally now with PPAs. And as Dick said, this is kind of something the regulators don't really track very carefully. But these PPAs have grown in importance over the last few years. And you can say, well, these are just financial agreements that are help financing. But when you look at the provisions of the contracts, it turns out that they have real implications for those short-term markets. And I'm going to give you some examples in a little while and suggestions for how to deal with them. So just to say something about batteries, this is from a study we did at MIT. It was finished in 2022. There are many different kinds of batteries. Some are in existence and used, so that's the case for lithium-ion batteries, basically developed first for EVs, and now used on networks. But they refer those as short-term storage. They're 2 hours to 4 hours typically of storage. And at least today, they're adequate for most applications. What makes them long-term, you can make a long-term lithium-ion battery, just put them back to back. But it would be expensive if you had to use them for 12 hours. And one of the many differences between batteries is that lithium-ion batteries have relatively low capital costs and relatively high, kilowatt-hour costs. So they're dense batteries with dense power, but if you want to run them for a long period of time, they're expensive. The technologies that are being developed redox flow batteries, thermal storage batteries, what are frequently referred to as long-term storage, have higher capital costs, but lower storage costs, lower kilowatt hour costs. And in the long run, we're going to need those as well to deal with long periods of time when there's no wind, or periods of time when demand is fairly high at night in a solar-dominated system. And our study is online. You can read it. It's kind of outdated. Yes, sir?
I have a question about the energy cost. Do you have some update from 22?
No, we haven't updated. Okay. But I'm sure the costs have changed.
Yeah.
Hopefully for the better.
More.
Yeah. But, I should say something about doing these studies. This was an interdisciplinary, so we had economists, we had scientists, chemists, and physicists. We had, obviously, quite a few engineers from chemical engineering and from mechanical engineering. And their notion of a good number for a cost and my notion of a good number for a cost are rather different. I wouldn't say they make up the numbers for the technologies that are in the future, but kind of do. Whereas for lithium-ion batteries, we had pretty good numbers for what the cost would be, because we had lots of examples of them from EVs and from applications in the US and other countries. There's just a comment on interdisciplinary research in terms of what people think is most desirable. Okay, so this is kind of an important part. Where is this demand for long-term PPAs coming from? So it's coming from a number of different sources. So the first source is states, like my state, realized they were never going to meet their commitments to decarbonize if they just let the market work. So they've gone out and done required and have managed procurements of wind and solar. And Massachusetts is Maine, Massachusetts, Connecticut, New York's very big on this, New Jersey, I'll come back to New Jersey, Maryland, District of Columbia, Illinois, California, although that's further in the horizon. They basically have said, okay, we're going to procure, and so far in New England and New York, 30 gigawatts of batteries of offshore wind by 2035. We've identified leasing areas, and we're going to incent developers to do it by taking competitive bids for wind generation meeting certain criteria. Another source are just load-serving entities, that is traditional utilities, in states that have decarbonization commitments and have required the utilities to go out and purchase wind and solar using 15 to 20-year PPAs. So in California, to meet their reserve obligations, the local utilities must purchase at least 65% of their generation under long-term PPAs with wind and solar and more recently batteries to help to meet the state's commitments. Massachusetts has done several procurements already. And you say, well, who's going to pay for this? Is Massachusetts paying for it? No, Dick said it. I'm paying for it. It takes a while. You got to follow the money. But it takes a while to figure out who's bidding. So the state runs the auction. They have a consultant who evaluates the bids. They assign it to the utilities. The utilities don't need the power. We have retail competition. Other people provide the electricity. So they sell it into the New England ISO. And if the prices they get are lower than the market price, the residual comes to me. It's a contract for differences that I never signed, but it's been assigned to me, basically. And the other, New York has such a complicated way of procuring, but in the end, the customers pay the difference between the market price and the going price. Okay, then there are independent power producers, and there are integrated resource plans, as I discussed, in states like Virginia and Oregon, where on a least cost basis, especially in the presence of federal subsidies, that their integrated resource plans going forward have purchases from renewables, zero carbon technologies, and they are typically either wind or solar, and they typically sign long-term PPAs with them to develop them. The primary utility in Virginia is a little bit different. It's kind of the old scheme. They're developing 2.6 gigawatts of offshore wind off of Virginia, and they're going to put the costs in their rate base. They're going to earn a rate of return on it, and they're kind of doing it the old-fashioned way. And they are the only project in the Northeast at the present time that's on time. A little bit over budget. They recently released a document saying that the proposed tariffs were going to end up increasing the cost of their project by $500 million. So it's not something to be sneezed at, but they will just pass it on to their customers. Then there are competitive retail suppliers. So I get my electricity from a company called netzero, since I'm in a retail competition state, and they offer products with various levels of greenness. And they go out and they sign contracts, or they develop themselves wind and solar facilities to meet those agreements. I won't go into that. We have an old law called the Public Utility Regulatory Policy Act that goes back to 1978, which I thought had died many years ago. And suddenly, especially smaller solar facilities are showing up. And under PURPA, they can demand that the local utility enter into a contract with them based on the avoided costs, the long-run avoided costs of the utility. And there are a number of states where they've tightened the PURPA regulations in Arizona, California, even in Georgia, to make it a requirement to sign contracts with these wind and solar generators that show up. And again, they're long-term. Then a big missed piece of this are corporate PPAs. A lot of companies, not just in the US, but in Europe, have made commitments to decarbonize their operations at some period of time in the future. Companies like Google, Apple, Amazon, all of the kind of tech-oriented companies have done this. So have nonprofits. MIT now had one, I believe it's negotiating 2 more PPAs for wind and solar generators, but not in New England. And this is a big issue about what really are you buying, but one in Georgia, a wind facility in North Dakota, and a solar facility in Texas. I'm not sure if that will come to, the last 2 will come to pass, but what are we buying? We're not buying electricity. You can't get it from Texas to anywhere because they have an isolated system. We're buying the green attributes. And then we'll count those when we look at this. We have a net zero commitment by sometime too soon to even think about, 2026, I think. And the idea there is we're increasing the supply of wind and solar, and we get credit for the environmental benefits, the reduced CO2 benefits. Now, there's a big issue. Are we really buying anything? Or would these have been developed anyway in the future on their own, or with some other PPA? What is really the incremental value that we're getting? And this is especially true today in the US. There are long queues for wind and solar generators to get connected to the system. So are we just replacing one facility, one owner, or one counterparty with another counterparty? I won't get into that. I happen to be on that committee, and I'm a difficult person to be on in that committee. But what is the really incremental value? So there are a lot of actions out there to develop these resources and to use PPAs to do it cheaply and quickly. Now, MIT has a AAA bond rating. It's now higher than the federal government's. And so we borrow money, at least up until now, at very attractive rates. So we can go to a developer and say, okay, we'll buy it. The developer then goes to a bank and says, okay, the offtake provider is MIT. They're really good guys. They have very good credit ratings. They're not going to go bankrupt. We have all kinds of provisions to require that they pay for the power. And then they can get financing at attractive rates. And in some of the ISOs, they can try to get to the front of the line to get connected by saying, we're ready. We've got the financing, we've got the offtake agreements, and so on. Okay, this is I just want to make a couple of points from this. These are some least cost simulations we did at MIT using an open access model, a system planning model called GenX, which is online. It only took an undergraduate working for me a whole month to figure out how to use it. But in that sense, it's open access. And the point I'd like to make is this. When I do these models, I say, let's do it with no carbon emissions limits. What would the system do just on its own? And this is New England. And those are gas plants. It doesn't do too well. Because as we saw before, it's not a particularly attractive region for these, for wind and solar, because the underlying resources are not very good. Here's Texas, no regulations. You get a lot of wind and solar, and really with no extra effort, and that's actually what we're seeing today. And then the Southeast is somewhere in between, with a lot of solar, still quite a bit of gas, and a little bit of wind, and that's nuclear in the Southeast. The model, this is when using models, you have to apply a little bit of external knowledge to it. The model wants to build nuclear plants in New England. It just loves nuclear plants in New England, even if you put in pretty high costs. The thing is, if you live in New England, the thought of getting a nuclear plant licensed, a new one, is really hard to imagine. So we just turned it off because we thought it was unrealistic, at least at the time frame that we were looking at. This is 2050. And maybe it would happen, depending on what happens to costs and safety and so on. But because of the nature of the underlying resources, it wanted to build them, even at fairly high costs. But we decided we wouldn't allow it to do that. Nuclear is an option that we want to give some consideration to down the road. So another point I want to make is when we make it very constrained, that's 5 grams per kilowatt hour of CO2, it's about a 95% decarbonization result. It's very little. The rest is natural gas with CCS here. So as you push them to meet very tough decarbonization requirements, they begin to converge because they've got wind, they've got solar, they've got nuclear, if it's cheap enough, and they've got batteries. The brown is batteries. But otherwise, they look very, very similar, but the costs are different. So in New England, the costs are higher, much higher. In the Southeast, they're lower. And in Texas, they're the lowest because they have good resources. And then finally, these are curtailments. That's the third point I want to make. These are situations in this model where the system is curtailed because in certain hours, there's too much wind and solar to meet demand. And as you can think about it, if you're going to meet demand with mostly wind and solar on the peak days in the winter or in the summer, there are going to be days when you have much lower demand and it's still windy and sunny. So you've got to turn them down. So curtailment becomes an important issue as the system approaches being fully decarbonized. And that's an issue with the PPAs that I'll discuss. Okay, this is another part of those simulations. Prices change. This is for Texas, ERCOT. This is what the price distribution looks like. It's got a lot of prices that are in this range, $5 to $50. As the system gets tighter and tighter, I wouldn't believe zero. This is an LP model. I don't know what happens when you get to zero. I don't know where it gets pushed, quite frankly. So if you look at 1 gram, that's 99% roughly, the price distribution changes. You get very few, you get a lot of prices that are just 0 to 5. They're really low. They're close to 0 because the marginal cost of these generators, they get pulled up a bit by batteries that are charging. And then you get a lot of prices that are really quite high, 200 to 1,000 compared to very few. And for a developer, this is kind of scary because we know already that when we get these price spikes, get them rarely, the public goes crazy about them, irrationally. They don't really see most of it. And then the ISO or the regulator comes in and caps the prices. We already have caps in most of the jurisdictions that are, the ISO is 1,000, 2,500. It's complicated how the caps work now. But you've got to worry that something's going to happen to this market down the road. And one of the values of trying to lay off this risk on a counterparty with a more diversified portfolio of assets and very high credit ratings is that you can lay off some of that market risk. And I can tell you it's not just the price risk. There's market design risk. As I said, ISOs have been in business, some of them going back to 1998, I think, the California started. There have been continuous changes in these over 25 years. And if you're in this business, that's a risk you have to take on. Not only do you have to take it on, you have to participate in these innumerable ISO meetings to discuss market design changes and then make filings with FERC, which then issues a temporary or preliminary order. Then you have to make more filings. Then they issue a final order for how to deal with it. Then some people go to court to challenge it. It takes years. So you kind of like to not have to worry too much about that if you can. But I think that's a hidden risk that is there that they'd like to lay off on others. Okay, this just shows for different technologies how much you're relying on the high prices to make them economical in the bottom here. So if you're down to 1 gram for a wind generator, you're getting most of your revenues from very high prices. So you've got to be pretty confident that those prices are really going to be realized and are not going to be capped in some way or diddled with, that's a scientific term, diddled with in some way that will be adverse to your interests, and kind of lay off those risks on JP Morgan or on Amazon, this is not a big deal for them, or on Apple and so on, is an attractive attribute of risk reduction. We're already seeing curtailments in California. So far, the green bars are curtailments due to transmission constraints, local transmission constraints. The blue bars are situations in which there's too much wind and solar being generated, and they have to cut it back. So it's a real phenomenon that's just emerging. And then here are negative prices. Negative prices are prices that emerge where the generator that's in the market doesn't get paid. They have to pay. It's not the most attractive thing to have that circumstance, but I'm going to show you why it is that the structure of many of the PPAs are going to lead to negative prices in situations in which there's relatively high supply and relatively low demand. Remember, high supply, these are intermittent generations. They supply when the wind is blowing and the sun is shining. They're not like dispatchable generators that are in an economic dispatch curve and they're used to going up and down. These are suppliers that are used to just producing if they can, and it's economical when the wind is blowing and the sun is shining. Okay, so here, they're actually, since FERC doesn't really follow this very closely, and neither does anyone else, the data on how many PPAs we're getting is relatively limited. So this is some data for PPA announcements in the US. And as you can see, they're going up. They're heavily focused on solar, which is a little scary because the sun doesn't shine at night. And if they're not putting in batteries and they're not getting an optimal mix of wind and solar, you can run into problems with solar-dominated systems. This is for Europe. Again, a big increase in PPAs. I think the European Union and the associated TSOs and utilities have decided that PPAs are the way they're going to make this work, make their aggressive commitments work. So PPAs are going up. This is different countries. I don't know why Spain has so many PPAs, and I know why the UK does, because it's their policy to use a government entity to purchase the PPAs and to be the counterparty. So it varies widely from country to country, depending on how aggressive they are at achieving these decarbonization commitments and other resources they may have, like hydro facilities or nuclear facilities. And this is PPAs through corporate power purchases worldwide. As you can see, those are growing. These are forecasts going forward for PPAs, very, very high growth rate. These are the kinds of industries, and I'll just point out here, data centers, technology account for more than half of the purchases. They're electricity intensive, again, not just Bitcoin mining, but for cloud computing, and increasingly for training and running large language models. Okay, these are the companies. I don't know how accurate these numbers are. I picked them up because no one really keeps track of them too well. But here's Amazon, Microsoft, Meta/Facebook, Google, Total, which is Total's French, right?
Yes.
Total's a French oil and gas company. AT&T is a telecom company. McDonald's, you know what McDonald's is. Verizon's a telecom company, etc. So corporate buyers are getting pretty serious about this because they've made these decarbonization commitments. Worth a discussion at some point, so why they've made these decarbonization commitments in the US, because they don't have to. They're doing it voluntarily. I think because their employees want it, maybe their customers want it, maybe the management wants it, but maybe they think it's cheaper than buying from the local utilities in their areas, but that's what's happening. And the cost, which went down for a long, long period of time, the real costs, have now flattened out, basically. So that the supply chain issues that have affected these projects since 2022 may be part of the recent story, but it looks to me like the costs, the real costs, have flattened out. Now this is in the face of higher interest rates and higher equipment rates costs. So they're still getting more efficient at what they're doing. Okay, so let's look at some of the problems. This is a simple fixed price PPA or fixed price contract for differences for all of the output from a particular facility or group of facilities. It's a fixed price of output. They take all the output. The buyer takes on all the output risk. The buyer takes on the price risk. This provides high-powered incentives to produce, because here we have, it's $35 a megawatt hour. The marginal cost is, let's call it zero. You're going to want to produce as much as you can. And that's first blush, is a very good thing. The fixed costs are all recovered through a megawatt-hour charge. That could be a bad thing. We'll see. The developer pays for the interconnection cost, and that has effects on locational decisions. And the LMP market price at the delivery location affects the price, reflecting congestion issues. Now, what are the issues with this kind of very popular contract? Well, the first issue, as I mentioned before, especially for wind projects, between the day the contract is signed and the day the generation occurs, equipment costs can change. And this is what's happened in the last few years. There are some European companies that have had some very bad financial results developing wind in the United States. Ørsted is one of them. And so that's a potential problem, that there's more risk, I think, than the developers thought. You're completely insulated from short-run price signals. Well, maybe that's the seller likes that, maybe the buyer likes that. The problem is there's no incentive. For example, let's take the simplest case. These projects have to be maintained. You have to take them down for some period of time, 4 weeks, 6 weeks, whatever it is. And if you're getting $35 a megawatt hour, you have no incentive to do it when market prices are low, like in most parts of the US in the spring. And so you just do it when you feel like doing it. It leads to negative prices. So if you're getting 35 and there's excess capacity, you're are willing to bid the price down all to minus 35. And if you've got a lot of participants in the market that are willing to do that, you're going to get these contingencies where prices basically fall to levels that don't seem to make a whole lot of sense, where the supplier is paying to run. That's a consequence of the structure of these PPAs. It may have other distortions. It doesn't provide you with incentives ex post to put in storage. One of the ways that projects are trying to deal with these potential curtailment situations and to conserve on interconnection costs is to put in storage. So when the price falls to, let's say, to zero, they store it up and use it later in the day when the prices are high. Well, if you're getting a fixed price, you have no incentive to do that. And then there's repowering. A lot of the wind generators in the US are being repowered. They were put in 15 years ago. The technology has changed. And if you want to repower, you've got to go back to the counterparty and negotiate a new contract with them and share the benefits in some way with them. And the sharing may make it economical, or it may just not be possible because the counterparty may not want to do it. So these kinds of contracts look simple. They look kind of ideal. Zero marginal costs. We pay for all the capital costs. But it leads to other distortions in the system. So people have figured this out, or begun to figure it out. If you look at some of the most recent contracts. So one thing they do, contracts now tend not to be fixed price contracts. We lived in a world with almost no inflation for a long time. And I know my kid and the kids of my friends, they all assume the rate of inflation is 1%. Well, I got my mortgage in 1978, it was 20%. I know what it's like to live in a high inflation environment. They don't. So they're indexing for inflation. All the new offshore wind contracts in the US on the East Coast now have indices that allow the construction cost piece to escalate with external construction cost indices. So you're contracting for a particular project, but you're also allowing the PPA price to go up according to the index in construction costs. As David Newberry has argued, basing this on modeled output provides attractive properties so that you don't get all kinds of gaming with the projects. They're starting to put in profit-sharing provisions. I just looked at a couple of offshore wind model contracts issued by Massachusetts, and they don't pay you if the price goes negative. You get nothing. It's as if the price was zero. And it turns out, and I haven't really thought about this, the reason they did it was not for the reasons I would have thought, that you get these negative prices probably create bad incentives, because they realized that the prospect of negative prices was raising the competitive bid price for the PPA. Because if it's a negative price, the developer has to pay. So they're basically saying, okay, the price goes negative, you can produce if you want, we're not paying. And we'll pay you zero. And I think that's an attractive development. Then two-part payment structures are emerging, where rather than rolling all the capital costs, am I running over? Yeah, rather than paying all the capital costs through a megawatt-hour charge, you have a two-part price. You pay for the capacity, and then you pay a much lower price for the energy to provide incentives to actually produce, but not but low enough that the incentives to bid the price down to very negative levels are much reduced. And then one of the attributes people don't realize is there actually is physical deterioration in these facilities over time. The estimates vary, but the contracts are starting to build into them allowances for physical deterioration, and that the amount of output that can be produced is lower. And the modeled output model that David has proposed actually is very attractive for this, because you can allow the modeled output to change over time as physical deterioration increases. Okay, let me just say a word about batteries. Batteries, and storage generally, but let's just talk about batteries. You really want them to interact with the market. Because you want them to charge when prices are low, and you want them to discharge when prices are high. And you don't want it to be distorted by a fixed PPA price. So what you really want to do is have a contract where you pay for capacity, and you pay for availability. So the contracts in California now that the investor-owned utilities are signing tend to be capacity price contracts, which allow the developer to keep the net revenues that they earn by charging and discharging, to give them incentives to make smart decisions about that. And then there's another kind of contract, which is basically a reserve contract, which gives the ISO the right to basically commandeer the battery to use during periods when demand is very high and supply, and they're concerned that there's a significant outage probability. So there's a lot of effort to respond to the rush to these simple contracts. Okay, let me just say a little bit about competitive procurement. A lot of economists think, well, this is a pretty simple contract. I take all your output for $35 a megawatt hour. In fact, if you look at the model contracts, they're 60 pages long. Well, how could that be? Well, we've talked about some of the economic provisions on prices and quantities and so on. But the way this works is you do two rounds. You do a competitive procurement. One and all come and give us what you offer. Then you reduce that usually to 2 or 3 finalists. Then you do a careful, individualized negotiation on the terms and conditions with each of those. And then you come up with a final winner. And in Massachusetts, you come up with a winner and a second winner in case the first winner disappears. And the kinds of things they look at during this negotiations: can you get financing? What kind of experience do you have? If Paul Joskow comes in and says that he's going to build a 500 megawatt wind farm off of Massachusetts, they look at me and they'll laugh. You don't have any experience doing that. They look to see if you've got site acquisition. In the US, you have to get sites offshore from a bureau, the Federal Bureau of Ocean Management, a bureau that used to be obscure. Do you have equipment contracts? What kind of maintenance scheduling are you going to have? Are you going to maintain it when the prices are low? How are we going to deal with curtailments? And so on. So these are big projects. They're billions of dollars. And you want to make sure that you have credible sellers and have provisions in the contracts that are designed to make them work more effectively, both in terms of construction times and in terms of operation. And if you look at some of these contracts, they're really quite detailed and quite long. Okay, let me just say a little bit about offshore wind. These are the offshore wind sites along the New England coast. As of January 19th, about between 30 and 40 gigawatts of offshore wind contracts were negotiated, and some are under construction and some are under final permitting requirements. And as Dick mentioned, there are all these questions. What comes first? Do you bid for the project? Do you wait until they have a lease? What about transmission? You have to get it to shore. It's not doing anything out there. And they've gone round and round about that, and there are some market power issues here. If you do the bid for the wind farm first, then it turns out you don't get many bidders for the transmission facilities, usually one. New Jersey, I think, got two on theirs. So Massachusetts' positions, we do them together. And I think that makes some sense. Then transmission is a very difficult issue. It's a generally difficult issue in the US. It's especially difficult offshore. There is no transmission offshore. And the connection to shore and offshore upgrades are currently treated as the responsibility of the generator, even if someone else, but basically it's a merchant project. The ISOs could coordinate design of the transmission, but by and large, they haven't done that. As a result, you have a lot of projects that have lines running to various points of the northeastern United States, but no offshore network. So here's an example. This is for New Jersey. They've been very aggressive. You see, each of their projects has its own line, which is a transmission line going to shore. And cleverly, the state of New Jersey and the PJM, the ISO, negotiated an agreement that the ISO would help to design both an offshore network and the onshore upgrades that are required. You can't just dump 2 gigawatts of power into Paterson, New Jersey. It's not going to work. And they did a very good analysis, and part of the deal, and Dick talked about this, part of the question was cost allocation. Who pays for this? Because New Jersey is part of PJM, which has progressive states like Kentucky and parts of West Virginia and parts of Ohio that they don't have decarbonization commitments. They don't want to pay for these offshore wind facilities. So the deal was New Jersey pays. We will allocate these costs only to New Jersey. And if we did this over time, we'd have more of a network that looked like this rather than these individual lines. But this requires not only for the ISOs to get involved, they actually have to cooperate with one another, which they have not been wanting to do. And you can build a much better offshore network than if you do it the way we're doing it now. And hopefully they'll come to their senses, and the other states will do what New Jersey has done. Now, I want to reinforce another point that Dick made. The decision to allocate the cost to New Jersey, because it was their public policy that required these offshore wind production facilities, it was pragmatic, but it's wrong, because there are benefits that go elsewhere to PJM. In particular, with all this wind coming in, the prices are going to go down elsewhere in PJM. And over time, who knows what the benefits will be inside? Who knows what federal law will be? Who knows what state law will be? And Dick is absolutely right. The way this should have been done was they said, okay, for the first N years, 5 years, New Jersey will pay, but then we're going to reallocate it. And we're going to see whether there are benefits from these offshore wind facilities that are being realized elsewhere in this large PJM ISO. And that was, at least initially, not a non-starter, but the right way to do it. So the conclusions, PPAs are playing a more important role than I think most people realize. They're kind of out there. They're not the responsibility of the ISOs, but they're very important. Much more attention needs to be paid to the structure of these contracts. I think the ISOs could play a consulting role in helping with this. The best practice of PPA design really needs much more attention, and policymakers need to be less insulated from what's happened in other countries. So I am amazed. I just spoke at a ISO, council of all the ISOs. They know nothing about what's going on in Europe. And I'm saying to myself, man, there's stuff to learn there. Why don't you just read a book or something? And they're just too insulated. And by the way, I think there's some of that in Europe as well, in terms of I've been reading all these debates about LMP, and it brings me back 20 years to maybe more than 20 years, 30 years maybe, to debates in the US. And the only thing I can say is LMP works. It's actually pretty simple now with the advances in the models. It may not be perfect. The advances in computing technology have made it much easier to do pretty complex calculations fairly quickly. And I think it would be worthwhile for us to learn from each other. And I will close with that. Thank you. I can take questions.
Okay. Any questions? Please raise your hand. No.
Thank you for the talk. I have a question about the cost allocation you were discussing about New Jersey. Mm-hmm. Was it decided that New Jersey would bear the cost because they were getting all the green certificates or to meet their state's obligations, or could those be counted towards other states? Because as it's in part of PJM, I know like Maryland gets a lot of carbon like regs from other states. So just a question of that.
You know, I think there were other ways of doing it, but this was pragmatic, and it was something that PJM would agree to. What FERC had done before this, I'm not sure entirely cleverly, I think Dick was already at RPE by then, is they created this class of projects called public policy projects, which were designed to harmonize the different state policies. And the basic idea was, if a state has a public policy that requires you put in new transmission, they should pay. That was so they kind of abandoned, in a way, their benefit allocation scheme. It does require more analysis. It also, as Dick said, the notion that you're going to figure out what the distribution of benefits are 30 or 40 years into the future is kind of unreasonable. So this was just a pragmatic situation. And maybe they'll reallocate it. Maybe Maryland will decide to join in with them. It's kind of got the same policies. They're buying from the same. So it's possible. But no one has 5 years to negotiate these things out when you're trying to put them out. And I'm sure as Dick will attest, when FERC makes major policy decisions, it takes forever. Maybe not completely forever, but it takes basically forever. What?
A little less than
never. A little less than never. Epsilon less than never. They eventually get to a conclusion. So this was just a pragmatic conclusion. Any other questions?
Any other question?
Yes.
What?
I have a question regarding this better designed PPOs, let's say. So they have been already given many gigawatts of PPOs with a standard pricing, fixed price, and so they distort the market already and
Yes.
pushing it into negative. So it means all the new ones coming to the market, they have worse conditions, but it's kind of not their fault because they just came later. Is there a way to maybe, I don't know, fix
You mean to
already the
renegotiate
old
the
ones?
contracts? Well, first of all, there's a long way to go till the U.S. is fully decarbonized, so there'll be more contracts. Another opportunity to do this is when they want to do repowering, or they realize that batteries might be profitable if they had a different structure, storage, on-site storage might be, and so you can renegotiate the contracts. It can be a long process, but you're absolutely right. Once you've screwed it up, it's hard to unscrew it, if I can put it rather crassly that way. And I think, but so far, the negative prices, except for California and maybe for Texas, don't occur that often. If you saw in that picture, they kind of grew over time, and they're still relatively small. So there's still time to be able to figure this out. Massachusetts, I just looked at their standard, their model. They figured it out. Just no payments when the prices are negative. So, and I think we're going to see more and more of that.
Because why I'm asking this, in Germany, like some funny things are happening. So before they were exempt from this rule, so only when the price is longer than for 6 or 8 hours negative, they were not being paid anything. Now for new installations, it's different. It's already from the first hour. But now what's happening is basically like solar in the south. They just shut down from the first negative hour, but then they cannot get enough energy like from somewhere else there. So they ramp up gas power plants, which really doesn't make any sense from the decarbonization perspective, but like this is a market setup.
This may have something to do with the way prices are determined in Germany. If you had a countrywide LMP system, I think you wouldn't have that problem. I mean, Germany, I haven't been there in a couple of years, but to me, this whole business is we want to have one price for the whole country. We don't even have one price in the same state. I mean, it's just not, consumers don't really see those prices. And, you know, they see them eventually in the retail prices, but they don't know why. I mean, I'll just tell you a very quick anecdote. One of my neighbors was complaining a couple months ago, and he said, God, I had this gas bill, and this electric bill, it was $1,200 last month. And I said, wow, that's a lot of kilowatt hours, just dividing it by the price. I said, show me your bill. So the first thing is, well, I've never seen my bill because they charge it to my bank, and I just see how much is charged. I said, well, let's get your bill. We can download it. He said, see, here's my National Grid bill. And I said, so that's interesting, but National Grid provides gas here, not electricity. That's actually your gas bill. So I think, especially for smaller customers, residential, small businesses, they're not looking at the details right now. For larger customers, they probably are, but I think, at least in my view, unless they can build substantial transmission between north and south in Germany, this is going to get worse and worse, and they're going to continue having patches to kind of make it work, and they're never going to patch it enough to really make it work. Yes, sir.
Let's go first.
My understanding of Germany, and it may not be the correct one today, is that if Germany was going to go to, let's say, nodal prices, I don't like to use the term LMP anymore, they would have to pay Poland for the price differences for the power that flows through Poland. And that was the major holdup in Germany going to locational prices. And my proposed solution to negative prices is to find the demand that benefits during
yes.
negative prices.
So of course that's true. So if there's flexible demand, obviously, being able to have someone pay you to take it is a pretty good deal. And the question is to find flexible demand that can do that. And we're getting more flexible demand, not just from petrochemical companies and oil refineries and so on, but with EVs, with heat pumps, with rooftop PV, with batteries. You can figure out, you can store it. Storage provides a way. You can put on standalone storage to just operate when the prices are low. So there are opportunities there. As you know, in the US, since every state has its own regulation, getting the states to understand any of this and allowing the retail customers, which they control completely, to be able to do this and to realize that they're actually part of an ISO with this complicated market is very challenging. But we have to do a better job.
Thank you very much also for the presentation. I have a question regarding like offshore wind farm developments and PPAs. So what we see also everywhere in the world now, the immense price increases in the procurement for assets regarding everything around offshore wind farms, like converters, platforms, and so on. And my question is, do you see already examples or also methods for offshore wind farm developers to hedge against that risk with PPAs, or also to share that risk with off-takers?
So I mentioned the latest model contract that Massachusetts has issued, which has escalation provisions for between the time the contract is signed and the time the project goes into operation. And it's not, we'll pay all your costs. It's here are indices of the major components, and we will build those, we will build those into the contract price, because almost all of the projects where the contracts were signed before the pandemic, they've all been breached. All but one that I know of has been breached. And there are termination provisions, so it's been a bad deal for the developers. But of course, the buyers in this case, they really want the projects. So they're willing to pay a reasonable price for the cost, but they've got to build in the fact that for whatever reasons, whether it's supply chain problems or just everybody building offshore wind at the same time, which was kind of happening along the east coast of the United States, is driving up component costs. You've just got to build it into the prices, or no one will do it.
Thank you very much. I was wondering, since the future of there is a lot of incentive or in the future for long-term PPAs, and I wanted to ask for the US, is there any effort to coordinate the allocation of PPA contract, given that there will be tendency for impact of negative pricing from legacy contract, like a form of a coordination process to allow for more securities or to help participant to hedge their risks in terms of, like, instead of having more bilateral kind of contract, the one that people just between two parties, similar like the way we have in Europe, like there's a coordinating entity that helps with this long-term allocation. Is there anything like this in the US?
Yeah, so we don't have any coordination entity like that, and just to be clear, the ISOs own nothing except their buildings, their software. They don't contract for anything. The idea has been these are financial arrangements. They're not our business, but they're going to have to be their business in the sense they have to provide some guidance as to the distortions caused by some of these contracts in the ISO markets. To say what kind of cooperation there can be, finally, you would think this wouldn't take so long. Massachusetts, Rhode Island, and Connecticut, but not New York, which should be involved, are going to do it together and to share the contracts based on their relative electricity demands in the states. New York's a big deal. It's a much bigger state. In New York City, they have the same decarbonization commitment as the rest of the state. But if you've been to New York City, you can see you're not putting a big wind farm in Central Park. There just isn't anywhere to put it, and there's congestion between upstate and downstate. They really should be coordinating with New Jersey, with Connecticut and Massachusetts, and Rhode Island's a peanut, but also a state, and doing it together and sharing the risks together and sharing the power and building the transmission network together. And the reason why the states have gone about this themselves, you know, we could ask a political scientist, but my 10-cent view is it's because there was no federal policy, and the states really wanted to decarbonize. And there are 25 states that have aggressive decarbonization commitments, and they really should be cooperating with one another and sharing the output, the risks, and the environmental credits they get.
I mean, this is what we have in Europe, of course, even on a regional level with this coordination. And the ISOs in the US, you don't have to own the property to help with the coordination.
Yes, absolutely.
The policy man, you can use simulation to help with the coordination.
As a general matter, the ISOs need to coordinate and cooperate with one another more. This is the lack of cooperation and the focus on the boundaries of each ISO is causing problems in other areas. So building transmission, long transmission that goes between ISOs, it's not happening, except for merchant projects that are basically ignoring the ISOs and just doing it themselves, but there aren't that many of those. And this is kind of the source of the problems with developing interregional transmission, which, if you saw my wind and solar map, if you want to access the best resources, you've got to be thinking about importing power from other locations. And that means coordinating on developing the transmission that's necessary. So you're completely correct.
Maybe I can ask the last very short
Sure.
question, Paul, the same question I asked Dick. If you wanted to do a PhD again, what would be your topic?
Well, I'm an economist. I got into this. I wasn't interested in electricity. I was interested in regulation, and somehow I got dragged into it with colleagues. I'm interested in what you do, how you deal with these decarbonization issues, but I'm interested in institutions, so I'm quite interested in these boundary problems between the ISOs and how we can better organize them to develop transmission. I've written some papers on this, and that's probably what I would work on right now.
Fantastic. Let's say thank you to Paul.